on with the next situation. Okay, for the next situation, you can see now the object is on 2F. Okay, object at 2F. Okay, the object at 2F. Okay, you can see we have the second row. Okay, the purple arrow is second row, and you have the orange arrow is the third row. Right. It is the third row. Then you can see the intersection. Here is the intersection, and the intersection is exactly on 2F also. See, if the object is at 2F, then the image will be at 2F also, and the size of the object and image is the same. Okay, size of the image is the same, and we have in intersection here. As I mentioned earlier, when we have intersection, it should be a real object. It should be a real object, and it can be formed on the screen. Can be formed on the screen. Okay, now let's try to draw this. Okay. Okay, this is next one. Now, okay, here is the object. Object is exactly on 2F. This is the object. This is O. O stands for object. Okay, let's try to apply second rule. Actually, you can apply all the three rules. You're going to get the same thing, the same characteristic of the image, and also same position of the image. Okay, let us try to apply second rule. Light which is parallel to the principal axis. Okay, here is light which is parallel to principal axis. It will be refracted towards F. Remember, I mentioned earlier, you must use graph paper so that it will be accurate. And the third rule is when light passes through focal point, okay, passes through focal point, and then it will be refracted by the lens parallel to principal axis. Okay, now you can see here we have an intersection of the two lines, and it should be exactly on 2F. Okay, here is the intersection. Okay, so okay, now let us look at the characteristic. It is real. Okay, it is real because there is an intersection of the lines, and then actually it can be formed on the screen, and it is inverted. It is inverted because you can see the image is inverted, the arrow direction of the arrow of the image. Okay, his eye is the image. It is inverted. And another one, is it magnified or smaller? Actually, I told you it is not magnified and it is not smaller, but actually it is the same size. The same size. Okay, so that is the next characteristic. So we have 3 characteristics. And another thing, you need to pay attention to the position of the object and image. The object is on 2F and the image also on 2F. Okay, here is the object. Sorry. Okay, here is the object distance U, and here is the image distance V. So in this case, U is equal to V. Okay, this is the next. Actually, this is the third case. Okay, this is the third case. Okay. Do you have any question? In this case, M is equal to V over U. Since they have the same value, then the magnification is 1. Means here there is no magnification in this case. That's why we have the same size of the image and object. Any question?